So, welcome to this presentation of a benchmark tool that we've developed for RonDB, and it will show you a little bit how you can use RonDB and how you can monitor RonDB. It is a tool that uses Locust, which is a Python program where you can write Python clients that issue REST API calls to REST servers. And so RonDB has a REST server that can receive hundreds of key lookups in a single request, handle those in parallel, and deliver the result as one result package back. So we have at RonDB.com, we have this presentation of this tool, and you can actually try it out yourself. So if you click this Try Now, you will get a pop-up window where you can provide your name and your email address, and you will get a mail sent to you that contains a link to a demo cluster that we have available. If you don't want that, you can read about the benchmark that we did, and I'll give you some more details about the benchmarks that we did later. So let's see what happens when you click this link so you can try it yourself. You will come to a page that looks like this. We call it RDRS demo control. So at the moment, nothing has happened. You haven't created a database, you haven't got any benchmark client up and running, and you haven't started your session yet. So your session you will be able to run this session for 15 minutes. So during those 15 minutes, you will have access to one database, and you have access to 2 CPUs in the benchmark client. And so the first thing we want to do is create the database. So we simply click on the yellow here, create database. This will create a database with 100,000 rows and 10 columns. It's a small database, but it's just for show. So we create the database here with 100,000 rows. Takes a few seconds. And then it says, click on Run Benchmark. So that's the next step. We start the Locust client. We don't start the benchmark with, just start a sort of web server that we can access the benchmark to start the benchmark from. So we click that. Now we're ready to go. So we can either open the bench UI to start the benchmark, which is obviously a good idea to start with. And then we can open Grafana to monitor what's happening in RonDB. So let's first open the bench UI. We get a page like this. We have 2 CPUs, so that means that we can run with 4 users. That means 2 users per CPU, which is kind of about what we want to have, because we spend almost half the time in the benchmark client actually. And then we specify the number of minutes we want the benchmark to run. So let's say 12 minutes, for example, and then we start it. And now it will quickly come up here and show us the results, and we can see that the average latency is 3.4 milliseconds. We haven't quite reached the limit yet, so we'll come up to around 1100 requests per second. So that means that 110,000 key lookups per second. And the latency of 99% is 5 milliseconds. So this includes network time, time in the Python client, time in the REST API server, time in the data nodes where we actually fetch the data. So let's now see how does it look from the point of view of the data nodes. So here we have another view. This shows the cluster in operation. So this one shows how the REST API server is behaving. And as you can see here, we actually have 2.65 REST requests per second, so a lot more than what we had in the one we had. And that's because I have actually a second benchmark client running at the same time, and it actually runs with 6 clients, so it gets about 155,000 requests per second. As you can see here, the latency is lower, and the reason is that this latency is measured from the time that the REST request comes to the REST server until the REST server sends the response. And that's less than half of the latency that we actually saw from the benchmark tools point of view. And we can see that the REST latency, 99%, is about 2.5 milliseconds. And we can see a graph here of how it goes up and down. So now there are other interesting dashboards we can look at as well. So the first one that sort of is the main page is the database. We see that we have 2 data nodes. We have a management server, we have a MySQL server, and we have 2 clients. And we can see that we're using about 95% CPU time here. And there are some things about disk write speed, networking, and locks, and there are some internal statistics as well. So, and there you can see here that you can actually look at both the data nodes. So you can either look at node 2 or node 3. And there are other dashboards. One is for checkpointing. Not much checkpointing happening since it's only inserting very small data sets. You can see here that there is actually a checkpoint happening here, and it took a few seconds and then it was done. That's actually, there's one here as well. So there are 3 checkpoints we can see here, and they all was done in very, very short time. So and we see that there are spikes here when we actually use the redo log. You can see that the redo log is actually used even when there is no load, and that's because we have to make sure that we are actually seeing some progress. Anyways, there's CPU activity. Here's some where we look at the CPUs from the data nodes point of view. So we can actually, this is measured inside the data node itself by basically calling the clock every now and then. So we differentiate between execute, sleep, send, and spin. Spin means that we don't really have anything to do, but we don't want to go to sleep because that would increase the latency. So we're spinning in a low performance. So we basically have special instructions in the CPU where you can have low-powered spinning. And so we make use of that to decrease the latency. Another date is detailed thread activity. So this looks at things from a thread's point of view and the operating system's point of view. So as you can see here, you have 60% spent in system time, in user time, and you have about 35% spent in system time. So the total is about 97% CPU time. And this includes spinning. So this shows the values from the operating system's point of view, whereas the previous one was looking at things from the database point of view. And it's the database point of view that's actually the most important one. We can also look at disk column operation latency. We don't have any disk operations, so there is nothing to see there. We can look at the redo log buffer, and there's very little writes happening, so it's a very stable environment we're looking at. And we can look at redo log file usage, same thing here. That mainly matters when you have a write load that's of significance. We can look at the memory. So if you have here, you can see that the total memory we have is 27 gigabytes. We use about 24 gigabytes for actual database data, and the rest is used for internals of the database, so like transactions, schema, changes, signals, message buffers, and things like that. And we can also look at the networking in more detail. As you can see here, we're sending about 17 megabytes per second in each data node. We can also look at operation latency. In this particular benchmark, it's not that interesting, but in other benchmarks, it would be more interesting where you have real transactions happening. Here we're only reading single rows, and that doesn't really make it possible to measure the latency, because we're not getting back to the point where we start measuring. Okay, and we have statistics about operations. We can see here that everything is local reads, and so there are reads, simple reads, and everything is local reads. So every read is a simple read, and every read is also a local read. So we don't do any sort of networking in order to read. We always come to read at the right place, because we have mechanisms to make sure that key lookups always goes to the right place when it's a simple read. And we have a page cache statistics for these columns again. No, and that is about it when it comes to the monitoring. And as you can see, we still have 5 minutes left, so we can just let it continue. If I go back to the RonDB.com, you see here we also have a video about our release. You can read about the benchmark. There are other blogs that you can read about. We also have a benchmark of older benchmark where we benchmark YCSB, which has a lot more writes in it. And we even measured what impact node recovery had on the benchmark. The benchmark we ran, as you can see, we reached 104.5 million key lookups per second via REST API. We used 6 data nodes with 64 CPUs, so pretty big cluster, but not the biggest you can have. You can have a lot more than that. We used 150 keys per batch. We also did a benchmark where we focused on latency, and we got to 61 million key lookups in that benchmark, and then we had 1.93 milliseconds average latency and 3 milliseconds P99 latency. So this was executed in a cloud with a little bit better networking. And as you can see, the networking really had to be good, because we reached 15.6 gigabytes per second in the response to the clients. So that means 125 gigabits per second. So obviously kind of big. So we had to have really good networks to handle that. What we showed here is some latency numbers where we can see that a single row latency is, say, something 1. And if we have 100 rows that we send instead of 1 row, the latency only increases by a factor of 2. So you can see here in the graph that going from 1 to 100 rows only increases the latency by 2. After that, it's a more linear approach where sort of the parallelism, we have exhausted the parallelism, but 100 keys we can handle without any extra latency almost at all. And it's the first LATS database, meaning low latency, high availability, high throughput, and scalable storage with up to 6 nines of availability. And that's it. Thank you for listening.